Hello friends, welcome to Simulation Card. In this video, we are going to see the field-oriented control of synchronous reluctance motor by using MTPA. So as you know, in FOC there will be two loops, outer loop and inner loop. In outer loop we have the speed loop. So the speed loop is coming from, it is starting from here. So this is the reference speed, and next to that we have the actual speed. So before getting into that, let me give you a wide view of what are the things we have here. So this is high voltage battery. It will supply a voltage of 600 volts. Then here we have the capacitor. Then this is voltage, DC bus voltage measurement. Then we have converter. Then we have provision for measuring the current. Then this is synchronous reluctance motor. This is torque measurement unit. Then we have the load torque. Okay, so inside this so this part forms the outer loop, that is the speed loop. So this is the reference speed. This is actual speed, which is measured from the motor. Then here we have the PI controller. The output of PI controller will be IQ reference, quadrature axis reference. So here we have the inner current loop. In current loop, we have two controllers or two parallel processing happens. Uh, the first one is for ID and second one is for IQ. This is the loop for ID, that is direct axis current reference, and this is the one for quadrature axis. So unlike induction motor or PMSM, here we need to process the FOC by using MTPA, that is maximum torque per ampere. So this MTPA block will give us the values for ID reference and IQ reference based on LD, LQ, pole pads and IMAX. So the output of this is VD and output of this loop is VQ. We are giving it to Park to Clark angle transformation block, and later on we are using the SVPWM to generate pulses. So in parallel to that, we have the option to measure IABC. Then IABC, the three-phase currents will be converted to alpha beta, and later on it will be converted to D and Q axis currents. So these two forms the actual direct axis current and actual quadrature axis currents. Okay, so let us run the simulation now. Yes, the simulation is compiling. So here we have the subsystem for scopes. Yes, the simulation has started to run. So we shall now open the RPM scope. So there is some initial disturbance initially, and later on it is settling. So here we have the comparison of reference speed as well as the actual speed. So the yellow color one represents the reference current, reference speed, and blue color one represents the actual speed. So I have given a speed reference pattern. So for 1.5 seconds, from 0 to 1.5 second, the slope will be a gradual slope, rising slope. The reference speed will start from 0 and until 600 RPM, the slope will rise. Then from 1.5 second to 3 seconds, there will be a flat surface. Then from time 3 to 4.5 seconds, the reference speed will be rising from 600 RPM to 1000 RPM. Then from 4.5 to 6 seconds, there will be a flat surface. Then from 6 seconds to 9 seconds, the reference speed will be dropping from 1000 RPM to 0. Okay, yes. As you can see, the flat surface has reached. So this flat surface will continue until 3 seconds. We shall parallelly have a look at the phase currents. Yes. So as you can see here, we have a provision to give load torque. Initially, the given load torque is 0.15. I mean 0 for 0.15 second, and later on, after 0.15 second, a torque of 35 Newton meter has been applied. Yes, as you can see, the torque is hovering around 35 Newton meter. Yes, the simulation time is now 2.8. So in a while it will reach 3 seconds, and then on it will keep on increasing from 600 until it reaches 1000 RPM. Yes, now it is increasing. So it will take a while. So to reach 1000 RPM, it will take 4.5 seconds. Yes, friends, the same model is available for download from our website. If you want to purchase this model, you can go to this website, and we can uh, get the details of this. And if you want to have one-on-one meeting with a developer, you can just click on this, and it can be added to the cart. Then we can you can proceed on to making the purchase. So if you want to purchase it in terms of US dollars, sorry. So if you want to purchase it in terms of US dollars, you can very well click this, uh, and you can proceed on with the payment. Okay. Okay, friends. Thanks for watching. Please subscribe. Please share our channel to your friends. Thank you again.